Today we're going to focus on factoring and we're going to work on the reverse distributive property, and we're also going to undo generic rectangles, a little review because we are factoring when we're doing that, because today is our first day of chapter 8 and we are going to be working with parabolas, and this is a skill that's going to be necessary as you find roots, as you use the zero product property. So we want to make sure that we feel very comfortable with this. Let's go ahead and jump into our notes. So our topic today, first of all, this is our first day of chapter 8. And it's always good to have that. That way you know that this is our starting page when we look at our notes. So our focus today, we're going to start with some factoring. And that is the reverse distributive property. Reverse distributive property. In fact, we are going to check our answer by doing the distributive property, by applying that to make sure that we're correct. So let's go ahead and jump in and look at the steps. And this is one of those things, just the more practice you get solving these problems, the easier it's going to be to recognize when and how you need to do it. So our first step is to look at the numbers. And you're going to look for a number that you can pull out evenly. That means with no decimal, from all of the numbers in every single term. So let's start with example 1. And there's going to be 5 from these top. We're going to look at 5x plus 20. So we're going to ignore right now the letters, and we're going to simply look at the numbers. I have a 5 and a 20. Now you can't take out more than you have. So the most I have in this term is 5. So I'm going to start with that one, and I'm going to ask myself, does 5 go evenly into 20 with no remainder? And it does. Use your calculator, 20 divided by 5 if you're not sure. So we're going to go ahead and we're going to take that number out. Okay. We're then going to start a set of parentheses, and we're going to go 5x divided by 5 simply leaves me my x. And then we have 20 divided by 5, which is positive 4. We're then going to go ahead and close that set of parentheses. So that is going to be our factored answer, 5 times the quantity x plus 4. So our second step, which we didn't have to do for this problem, we are going to look at our variables, our letters. And in order to take a variable out of a set here of terms, it has to be in every term. Now, there can be more than one. It could be something like x squared and an x, but there has to be in every term. So in this case, I have a 5x here, but I don't have an x over here, so I can't take it out because it's not in both. You can't take out what you do not have. And then our third step and final step for this is to check. And the way that we check is very simple. We are simply going to distribute. Now, when we distribute, we should get the same answer. So 5 times x is 5x, and 5 times positive 4 is 20. So we know that we got that correct. Let's go ahead and try a couple more. The second one, 6x plus 15. Okay, so here we're going to go ahead and take a look at the numbers first. I have a 6 and a 15. So I look at my biggest number and I ask myself, does it go evenly into 15 with no remainder? 6 does not. So 6 times 2 is 12. 6 times 3 is 18. So I know I can't take all of the 6 out. Once I do that, I want to see if I can take something else out. So I look at the factors of 6. So I know 2 times 3 is an option, and I look at the bigger one. So I ask myself, does 3 go evenly into 6? It does. 3 times 2 is 6. And does 3 go evenly into 15? It does. 3 times 5. So we always want to take out the most that we possibly can. So we always try with those larger numbers first. So we're going to go ahead and take that 3 out. I look and I see there's an x in the first term, but not in the second, so I can't take an x out. So if I take a 3 out, 6 divided by 3 leaves me 2x. And then I see my 15, I take 3 out of that. 3 times 5 is 15. So what I have remaining is 3 times the quantity, 2x plus 5. I distribute to go ahead and check. 3 times 2x is 6x, and 3 times positive 5 is 15. So I know that that one is correct. Okay. Here's one, and we're going to bump up that level of difficulty. So we have for problem 3, 8x squared plus 20xy. Okay, so we're going to start with our numbers. I have an 8. That is my big number here. And 8 does not go evenly into 20. I know 8 times 2 is 16. 8 times 3 is 24. So that does not go in evenly. So I'm going to look at the number smaller than 8. So I know I have a 2 times 4. 4 is my larger. 4 does go evenly into 8, and 4 does evenly go into 20. So I know I'm going to take 4 out. Then I look at my variables. I have 2 x's here, x times x, and I have a single x here. So I know I can take an x out because I have an x in each term. I have a y here, but I don't have a y in my first term, so I have to leave the y there. So what I'm going to be able to take out to factor is I'm going to factor out that 4x. So what I have left here, 8 divided by 4 is 2. I take one of the 2 x's out, so I have one more left, plus 20 divided by 4 leaves me 5. I'm taking that x out, but the y remains. So my answer is 4x times the quantity 2x plus 5y. I'm going to distribute to make sure I have the correct answer. 4 times 2 is 8. X times x is x squared. 4 times 5 is 20. Then I have an x and a y. So perfect. And so I have factored this expression. Okay, let's look at number 4. We have 2x to the third power plus 4x plus 3y minus 12. Okay, so we're going to start with our numbers. Our smallest number is 2, and we're going to see if we have an even amount to take out from each one. So 2 goes into 4 evenly. 2 does not go into 3 evenly. 2 does go into negative 12. Now remember, it has to be pulled out from all numbers, and it can't be pulled out of that 3. And the only other number that I can get to is a 1, and pulling 1 out doesn't do anything. So I can't take any numbers out. So let's look for our variables. I have an x here, an x here, don't have an x here, don't have an x here. I have a y here, but I don't have y in the other 3 terms. So there is nothing that I can factor out. And so this is the case where it is already factored. And it's probably the most important one that we can look at. And that's because you want to know, you have to know when you're done factoring. So if it's already factored, you're done. You need to be able to recognize when you're done factoring or if there's something more that you can take out. So in this case, that one is already factored. Let's go ahead and try one last one of these, and then we're going to remind you how you do this in a generic rectangle. So our fifth example here is 3x to the third power minus 6x squared minus 12x. So once again, first we take a look at our numbers. We look at our smallest number because the most you can take out is what you have. So we can't take 6 out because that's smaller than 6. We can't take 12 out because that's smaller. So we always look at that smaller number, and I see if it goes evenly in the other term. So 3 goes evenly into negative 6. 3 goes evenly into negative 12. So I can go ahead and factor out a 3. Now I'm looking for x's. I have 3 x's here, 2 here, and 1 here. So the most I can take out is a single x because I only have 1 x at the end. So we're going to go ahead and factor out that 3x. When I take 3 divided by 3, just leaves me that 1. I had 3 x's, I take 1 out. That means I have 2 left. Negative 6 divided by 3 is negative 2. I have 2 x's, I'm taking 1 out. That leaves me 1. Negative 12 divided by 3 is negative 4, and I'm taking out that only x. So my answer is 3x times the quantity x squared minus 2x minus 4. Let's double check. 3x times x squared is 3x to the third. 3x times negative 2x is negative 6x squared. And 3x times negative 4 is negative 12x. Therefore, this one is factored now. Okay? Excellent. Now, one of the reasons why we work on factoring so much, like I talked about earlier, is because a part of what we're going to be doing in this chapter is to take a generic rectangle and we're going to go ahead and find out what is the outside of it. And we've already worked on this before and have a set of notes previously on this as well. So if this is my example, 6x squared, 8x, negative 3x, and negative 4. We know that what this is the quadratic equation 6x squared, combining like terms, 8x minus 3x is positive 5x minus 4. Okay, so this is our parabola, and we know it has a y-intercept of negative 4. Now, the reason why we're going to learn using a diamond problem how to split this up, and when we split that up, we're going to split that 5x into the 8x minus 3x. And then your job is going to find the outside or the product, and we're going to use that to find the roots, which is where the x-intercepts of your parabola, where your parabola crosses the x-axis. So we're going to look this direction, and we're going to factor out everything we can. So we have a 3 and a 6. So the most I can take out is that 3. And there's an x in both. There's 2 here, 1 here, so I can take a 3x out. Okay. Looking this way, I have a 6 and an 8. 6 is my smallest. It doesn't go evenly. So I'm going to look at that 2 and 3. The 3 is bigger. The 3 goes into 6. 3 does not go into 8. But the 2 goes into both. So I'm going to take a 2 out. I have a 2 x's here and a single x here, so I can take one of those. I double check 2x times 3x is 6x squared. Going this way, I have an 8x and a 4, so the most I can take out is 4. Okay, and then that checks out this way because 4 times 2x is 8x. And finally, I have a 3x, and it needs to be a negative 3x. And so that's going to be a negative 1. Now, if I look this direction for factoring, I have both negatives, but 3 doesn't go into 4 evenly, and I don't have an x in both. So all I can take out is that negative, which is negative 1. Now, when I rewrite this, it becomes 3x plus 4 times 2x minus 1. Okay, and these are going to be how we find the roots using the zero product property. So in our future lesson, we're going to set each of these equal to 0. And then we're going to go ahead and solve for x. So 3x is equal to negative 4. Divide both sides by 3. And x is equal to negative 4/3. Over here, we're going to add 1 to both sides. 2x is equal to 1. Divide both sides by 2. And x is equal to 1/2. So these two x's are the places where our parabola is going to cross the x-axis. And so, ladies and gentlemen, we need to make sure we remember how to do this so that we can then find our intercepts, and then we're going to go ahead and add those together, divide by 2 to find the x of our vertex, which is the lowest or the highest point, plug that into our original equation. So this set of notes today, ladies and gentlemen, is setting us up for all of Chapter 8. So make sure that you're really focused, make sure that you're really paying attention, and you're looking for all those ways that we can factor, because a problem is not officially solved until it is properly factored. Let's go ahead and practice in our Desmos activity.